In the previous video, we created a Laravel application from scratch, and we assumed that we would have nothing but Docker installed in our machines. We also configured the development environment with Docker Compose, and now our team is ready to build amazing features. Let's talk a bit about containers and production. You might have noticed that in our development image, we are not copying our application source code as one of the image steps. That's because we have been relying on Docker Compose to map our application files to the container. This works fine for development, but we should change it for production. The production image should be self-contained, which means that it must have everything it needs to run, except maybe for a few configurable bits. However, we are going to talk about configuration in a later video. For now, it's enough to know that we should keep everything that is secret outside of the image itself. We should change our build steps in our image to generate everything our application needs, which includes OS level dependencies, application dependencies, compiled assets, and the source code. We are going to tackle all that in this video. Let's start by copying the existing Docker file and tweaking it for production. So we are going to create a new folder in the Docker folder called PHP. And inside there, we are going to create a new Docker file, which we're going to call prod.dockerfile. And there we are going to copy our local one and paste it there. I'm going to delete this part because we're not going to need it. Now we need to install our Composer dependencies. If you remember from previous videos, we installed Composer in our image using multi-stage. And if you remember, I mentioned that we are using multi-stages here, and that's because we are copying the binary from an image that was built somewhere else, not in these statements. To understand more about multi-stage builds, I recommend checking out the documentation on Docker. Let's make use of multi-stage images here. We are going to start by creating another from statement here, and before that I'm going to add a comment here with Composer dependencies. So I'm going to add another from statement. And in here, I'm going to set the work directory to be the same one as this one. Now we actually have to copy the composer.json and the composer.log files to run the composer install commands. See that I'm not copying the entire application, just these files, because this is enough to actually install the dependencies via Composer. And now we can actually install it. But before we run Composer install, we actually need to change something. So if we go back to the Composer.json file and we check the autoload section, we see this class map. Composer uses this to generate the autoload. And it requires these folders to exist. But they don't exist here because we are only copying the files that we need. What we can do is actually create the folders ourselves. And now we can actually install it. So we're running Composer install, we're ignoring the development dependencies, we're saying that we prefer the dist, and we don't want to execute any scripts, because if you remember, Laravel hooks in Composer events and runs some scripts, and we don't want that. So at this point, we are actually not worried about scripts, autoloader, or anything. We just want our application. We just want to download the Composer dependencies. And we also don't want to check platform requirements. So by default, Composer, when you run Composer install, Composer will check if the environment has every extension that we explicitly require here. And if it's not, it will fail. We don't want to do that at this stage because that's not the real production environment, which means that we are going to have to run this as well as the autoloader in our actual production image. So I'm going to add a comment here, actual production image. Next, we need to do the same but for the npm dependencies. So I'm going to create another multi-stage. And I'm going to extend node 12 and call it npm builder. I'm going to set the work directory also to var www.html, and I'm going to copy the files required to run npm. Differently than in our composer stage, for the npm we actually are installing and compiling the assets. So that's why we are copying the webpack.mix.js as well. And we also need two other folders, and I'm gonna do that here. So I'm gonna copy the resources folder to /var www.html resources. That's where our front-end assets are in Laravel, and I'm gonna also copy the public folder. And I'm doing that because Laravel Mix will compile our source code and it will output in the public folder. We can check our mix file here, and this is what it's doing. Yeah, now we can actually add a run statement and run npm CI to install the dependencies, and another one for compiling the assets for production. So with that, I think we are fine here for now. So let's try it out. I'm gonna go to the terminal and I'm gonna run build, docker build, and I'm gonna set a tag here and I'm gonna call it docker for Laravel PHP, which is this image. I'm gonna actually test docker for Laravel PHP, and I'm gonna specify the docker file, which is under .docker php prod.php, and I'm gonna give it a context, which is the current folder. Let me stop here, and you can see that it actually sent 1700 megs to the Docker daemon, and that's because it's actually sending the npm modules and vendor folder, and we don't want that. So let's go ahead and create a .docker ignore file here, and let's ignore the vendor folder and node modules folder, as well as the git folder and our idea folder, which is my IDE, creates one folder here as well. And let's also ignore the .env file because we don't want to ship that in our production image. And also our tests folder. We don't need that in production. And with that, I think we are fine now. So let's try again. You see that this time it only sent 2 megs. And I got a failure here. Oh, of course, I forgot the -p flag. So now let's try again. So now that our image is done, and it took almost 3 minutes because it downloads all the composer dependencies from scratch, no caching. Let's inspect our image. If we run a container from that image and run ls inside of it, we see that there is no files on it because we copied our PHP part from the development image, and that relies on Docker Compose. Yeah, there is no files on it. So we need to copy the files, as well as we need to copy the public folder from the npm dependencies and the vendor folder from the composer build. That part is done. Remember that I actually said that no autoloader was generated and no platforms requirements was checked. So let's see what happens if we try to use this image. Let's build it again. So we got an error here. It's trying to pull the npm build, which means that we might have a typo here somewhere. Yeah, here should be npm build to match the composer build. So let's try it one more time. Okay, now it's done. Let's test it out. How can we test it? We can change our Docker Compose file, comment out this part, and add an image here and use our local image. And now we can bring the application up. Everything seems to be up. Okay, let's try to open it in the browser. And now we see an error. The autoload is missing. Yeah. See, now we actually have to generate the autoload and check for platform requirements. And we do that in the final image because that's what's going to run in production. So we want to make sure that we are not shipping an image that doesn't have a required dependency. Let's generate the autoload, and check for platform requirements. So now let's build it and try one more time. Now we can go back to the browser and refresh. You should see an error, not sure what that is, but let's debug it. I'm gonna set an environment variable here to equals true. I wasn't expecting the error, so let's debug it together. I'm gonna bring it down and up again. Now let's refresh the page. Yeah, this is fine, I think, because that means that we don't have the application secret, and that's because we are ignoring the .env file, and this had the application secret, so like that's fine for now. If we had it here, for instance, and we refresh it, I need to bring it down and up again, and we refresh it, we should see yeah, everything seems to be working fine. Let's see the assets. Oh, we're loading, so we're fine now. Now I'm gonna remove this part. And if we go back to the PHP image on Docker Hub and we look for production here, we'll see a mention that it's actually ships by default with the ini settings for development, and we need to use the production one. The production ini configurations, they ship inside the image itself, so you can actually just copy it. And also, since it mentions here, we need to enable and install OPA Cache in our image, so we are going to do that now. I'm going to copy these lines and I'm going to go back to the image and place them here. And I'm going to change this to actually be Docker PHP, and we need to create the OPA Cache file. Before we configure it, we actually have to install the extension. So we have to install OPA Cache here, otherwise it doesn't come installed by default. So let's configure OPA Cache. If you don't know how to configure it, there's this blog post from Laravel News, Paul Redmond. You can check that out. If you want to know more about configuring OPA Cache and other things, I highly recommend this book, Scaling PHP. It goes really in depth on tuning for production and taking most of PHP and HA proxy and all that. So yeah, go check this out. It's amazing. And I'm gonna copy this, and we are going to use this and tweak it a bit. As it mentions here, we probably want to set this to 0, which means that it will never revalidate. So without OPA Cache, PHP will actually check the files on every request, interpret the contents and generate bytecodes and execute them, and then dump everything for the next request. And that's actually slow because PHP is reading a file on every request. And to avoid that, we have to enable OPA Cache. OPA Cache, the way OPA Cache works is that it will interpret the PHP file the first time, generate the bytecodes, and keep that in memory. So every time it receives a request that touches the same files, it will read the already in memory OPA Cache instead of rechecking from file. So with Docker, every time we are going to deploy the application, we are going to generate a new image, and we are going to deploy that image to new containers. So Kubernetes, which is what we are going to be using, will delete the existing containers and create new ones for the new image. So we actually don't have to recheck the files frequently at all, because the containers, which is essentially the server, the PHP process, will be deleted on every time a new version is shipped. And this says how many files we actually want to limit. And you can actually use find in this folder any file that is named PHP. We want to count that. And there are about 6,000 files. I'm going to leave it as 10,000 here, just in case. And for memory consumption, you actually have to explore your application and see how it behaves. Another good resource on OPA Cache configuration is this blog post. It goes over many edge cases and how you can actually observe your application to better fine-tune the OPA Cache configuration, so go check that out. So let's try it out. If you're using Docker locally, you can run Docker stats and you have statistics on how your containers are running locally. And let's create a new tab here, and I'm gonna run an A/B test for 500 requests, 10 concurrent. I'm gonna hit the login route, which should be enough for the test. Yeah, 60, 70, that seems to be it. I'm gonna leave it as 128, and the rest I'm gonna leave as is. And now we actually have to rebuild the image. And so what's interesting here, if you see here how many requests per second this container without OPA Cache can handle, it's 30. And let's build the image. Let's bring the application down first. Build the image again. So now that that's done, let's try it. I'm gonna bring the application up, and we are going to run the A/B testing one more time. And remember that we ran 27 requests per second. Now we have OPA Cache enabled, so let's see how long it takes. This time we were able to handle 240, 250. I'm recording the video here, so you might handle more. You might be able to handle more in your configuration. So now OPA Cache is installed. Let me show you something. So let's say, let me close this, and let's say one of these steps failed for you and you want to debug it. So let's say this one failed, and this is the hash that failed. If it's step 17 had failed, you would never have this hash, but you would have the previous one. So what you can do is you can actually run container using that hash and get a shell, and then you can see what happened. So let's list the files, and you can see that there's nothing here because the files are only copied after that. So now you can actually debug and run your commands here and change your Docker file back and forth until it works. So with that, the PHP image is done. Now let's talk about that EnergyX. So if you remember, EnergyX, we are actually not using a custom image, but we are going to need it for production. And let's go ahead and create a Docker file here for EnergyX. So I'm going to call it prod.dockerfile, and we are going to base it from, let me copy from the Docker Compose, and we actually have to copy the site configuration, and we are going to place it in the same location here, and we have to create a production one. We could use the same one, but there is a difference. Let me create a file and then we talk about it. Locally, we are relying on Docker Compose service discovery, and since we are deploying on Kubernetes, both EnergyX and PHP FPM containers are going to be running inside the same pod, so they can actually share the same network, which means I can send the request to localhost, and Kubernetes will handle everything. We actually need to copy our files to the EnergyX container itself. See, EnergyX is actually the web server, so it will handle web requests, and every time it receives a request that matches with our location for PHP, it will forward to FPM. So our assets file, they need to live in the EnergyX folder, but they also need to live in the production PHP image, because let's say we are sending an email that relies on assets or anything. So they need to live in both containers, and that's a bit weird, but it is what it is. So let's copy the npm dependencies. We don't need Composer because we only need the entry point for EnergyX, which is the index.php, and we are going to copy that from the npm dependency. So we are going to add a stage here, mood stage here, and we are going to copy the same line. Let me get there. Yeah, we need both. So now we actually need to build this image. So let me copy this name, go to the terminal, and we are going to build it. I'm gonna set the context. Since both mood stages ran in the same machine, it actually reused the same stages as the PHP image, so you don't need to worry about the npm dependencies installing twice, because Docker will handle that. And I think this is done, but actually, To test this out, let's bring this back to PHP and build it again. And now let's use this image locally. So I'm gonna comment everything but the port forwarding, and I'm gonna change this to use our image. Well, this should be EnergyX. I messed it up. So this should be EnergyX, and we should build the other one as well because we overwrote it. So let's try it out. I'm gonna bring everything down and bring it up again, and we can see if it works. Let's refresh here, and we got the server error, but remember that's because we are not copying the .env file. Actually, let's copy it. So let's create a volume, and we are only copying the .env file. Let's restart, refresh, and we should see everything working. So that's awesome. Now let's push the image. I'm gonna undo this change, and I'm gonna undo the change here for the production file. And this is it, I think. Let's rebuild the EnergyX because we changed the configuration. Okay, now we are ready to push this image, but before we do that, let's give it a better name. So we are going to run the same build command, but instead of this test name, we are actually going to call it ToneSM, which is my personal organization or my personal account on Docker Hub, and Docker for Laravel app, and I'm gonna call it, this one is the EnergyX, so I'm gonna call it EnergyX. I'm gonna tag it 001, and I'm gonna do the same for the FPM version. So now we can actually push these images. So let's also push the EnergyX one. Now let's go check out the Docker Hub, my personal account, and there should be 2 new images there. So these are the ones that we just pushed. So that's it. These images are public and are ready for us to use it. In the next video, we are actually going to create our Kubernetes cluster in DigitalOcean, and in the following one, we are going to make use of these images to deploy to the Kubernetes cluster. So stay tuned.